Any other ones that you're just not sure about? Yes.
On number 2, I said if all real numbers greater than -5.
Okay.
Because it was not a white one, so I didn't say not including 5.
But you have to say that it could be equal to 5, to negative 5.
Something that isn't equal to 5, but also not including 5.
Hang on. So this one here, right? Yes? Are you talking about the domain or the range? I guess they're the same, right? Okay. So your domain is all real numbers greater than -5, but also equal to -5 because it's a normal point. Is that
And I didn't say not including 5 because it was not.
right? Yes. So don't say not. Hang on.
I didn't say it was including it, but I didn't say it was including. So I just said all real.
No, that's fine. Well, you have to say where you. Yeah. Sometimes it's like a gray area, like what you apply. You know what I mean? You want to say where it's equal to. Okay. Yeah. No, you have to do where they exist. So if you say all real numbers between 2 and 5, it kind of depends on who you're talking to and who reads it, whether or not they include 2 and 5 or they don't include 2 and 5. So it's just better to be specific. Does that make sense? Okay. Any other questions about this one or another graph? Okay. Now I want to show you some very common mistakes. If you have your phone out or your headphones in, I need you to put them completely away. Yes, sir.
I had a question about number 8.
Okay.
Domain.
Yeah.
So do you have to include 3, 5, and 7, or can it just be 2 and 9?
Okay. Good point. So on question number 8, this is one of the ones I need to talk about. Some people say that the domain is the numbers 2 through 9. Is that the same thing as what I said?
No.
No. Because if you say the numbers between 2 through 9, you're including any number that could fall between 2 and 9. So you're including 2.1. Is there a point at 2.1? No. You're including 4. Is there a point at 4? No. So you cannot say that. You also cannot say, some people tried to say all real numbers 2 through 9. Are you going to use all real numbers here? No. You only use the all real numbers when there are too many numbers for you to write down. If there's an infinite amount of points, you can't write all those down. Now, how many points are here? 5. There's 5 points. There's only 5 points. You have to list the 5 points. Does that make sense? So there's really no way to shortcut that. Any other questions about that one? Okay, any other questions about any of them?
Oh.
Yes, Sheree?
Oh.
Hang on.
I think number 5.
Number 5.
That's the one I was thinking.
Oh, good. Number 5. Okay, number 5 is a little bit deceiving because it almost looks like this graph goes straight up on the ends, right? Okay, it doesn't. And if this graph was the size of this board, you would be able to tell that because the bigger a graph is, the more specific you can see where its points lie, right? You kind of have to have a little bit of prior knowledge, and you have to remember from Algebra 1 that a parabola, this is a parabola shape, right? A parabola is a quadratic, and because it's curved, it will continue to curve. So it will never become a straight up line unless you mix it with another equation. So this curves, but not very much, right? So eventually, will you have an x value at 10? Yeah, it might take a long time for the graph to get to x is 10, but eventually it would get there because of the arrow. Does that make sense?
Yes.
Okay, so the domain is all real numbers because it's a parabola and we know that it's going to continue to go out. It's just going out very slowly, okay? Does that answer all your questions about number 5?
Yeah.
Okay, the other one that's a lot of mistakes is number 4. Look at number 4. Number 4, most people are okay with the domain. My x values are all between -5 and +2. Raise your hand if you got the domain right on that one. Okay, a lot of people get confused with the range. There's 2 very common mistakes that are made. Some people say that the range is from -2 to +3. What's wrong with that? That's not the whole graph. ask you for the range, I'm not asking you what y values to your endpoints go. I'm asking you what are all of the y values that have to be used to create this picture. And if I want to know the whole picture, I need to say I'm going to use from -7 to +4. That's how, or 3. That's how you create the whole picture. Does that make sense? So don't get deceived. It doesn't have to go endpoint to endpoint. It has to cover the entire graph. You can't cut it off. What's the other mistake you think people make on this question?
It's saying not
Confuse the
including.
Y.
Some people say it's not including what number? So it's the range, right? Some people say it doesn't include what? Okay, some people say it doesn't include -7, but does it? It has to include -7 because it's just a normal point on the graph. If you're just at a normal solid point on the graph, you're always going to include it. You only don't include it when it's a very obvious hole, right? So the -7 comes from a closed situation. The 3 comes from a hole. Very good? Somebody in the last period wanted to say that the range of this graph is from -7 to +3, not including 3 and not including -2.
But there's two negative.
Because there's 2 of them. So what they did was they saw the hole and tried to exclude it. But when Will says there's 2 of them, he means when y is -2, there are 2 points on the graph that go with that. This hole and this normal solid point. If one of them is solid, you're going to include it in your answer. Does that make sense? So don't take this one out of the range. Any other questions about the range or the domain? Okay, any other questions about any of the graphs? Yes, ma'am.
On number 6.
6. Okay? 6. What's wrong with number 6? What's your question about 6?
So I get why I got the domain wrong. But
Okay.
the range, why does it say greater than or equal to 100?
To 200? Okay, because the range of this graph is starting here at 200 and going above, right? So it's going to continue forever that way. Now, is there a big marked endpoint here? No, but can we see what's happening anywhere else? And there's no arrow. So we have to imply that that's just a normal point on the graph at 200. It's not a hole, it's not an arrow, so it's just a normal point. So it's going to go from 200 on.
I thought it said 100 because I read it wrong.
Oh.
So that's why I was
It's a 2. It's just a very sharp 2. Everybody else okay? Okay, I did make a mistake on number 7. Can anybody find my mistake on number 7?
Run it, ticket, right?
Yeah.
Oh. Oh wait, I have to know the answers. I should answer your number.
I'm not going to type. Yes, ma'am. Sri.
Is it the domain?
What about it?
You put it's greater than or equal to 0, but isn't it 5?
No, the domain is 0. The domain is 0 because we're looking at the x's. And yes, it's at 5, but that's for the range. So my domain is still 0 on. So guess.
Who would be
4.
What? Yes?
Is it saying greater than or equal to 5 when it's not 5 because it's still going that way after the greater?
What do you mean? Because it's still going up?
Yeah, no, like it's not straight up, so like keep going.
No, that is correct. Because if we go up this graph, if we talk about the y values that would create these points, it's not straight up, but the numbers are still increasing as we go, right? So that greater than or equal to part is right.
Is it multiple?
No. Yes.
It's just right below 5.
Okay, so he says for the range it's right below 5. Okay. No, I read it as being a real intersection. That's not the mistake. Look at the graph really close. Yes, Will.
Oh, yeah. And that little blue thing at the end,
Uh-huh.
at the line, that is that?
Oh.
Nope.
Sorry,
So-
one, that 1 doesn't start on 1?
no, it's
What
It's
do you
in
mean?
thousands.
Oh, it's 0.5. Wait,
It's in
no.
thousands. It's in thousands. It's in thousands.
No.
On the side of your graph. As we're talking about the East Colony, it's in thousands. So, my domain still correct?
Yes.
Yes, my range should have said all real numbers greater than or equal to 5,000. Everybody got it? Okay, don't fall in the same trap that I fell into. Okay, any other questions on this graph? Okay, here's the next thing I need to tell you. Graphs 8 and 9. Graphs 8 and 9 are what we call discrete graphs. The rest of them are continuous. 8 and 9 are discrete. The rest are continuous. So think about that. What makes something discrete and what makes it continuous? Talk to your table and come up with an answer.
Continuous is the arrow.
Continuous is when it's
Okay, what makes something discrete? Just a dot. What makes it continuous?
There's a line.
It's a line. The arrow does not. Okay, this is the biggest mistake people have with continuous. A lot of people think that in order to be continuous, you have to have an arrow on your graph, and that is not true. When you use the word continuous in your normal, everyday English lives walking in the hallway, you typically mean that it's something that never stops, right? Continuous in math does not mean that. Continuous in math means that between any 2 points, it doesn't stop. So no matter what 2 points I pick on this graph, between these 2 points, do I have any stopping points? No, it doesn't stop anywhere between them. Does it stop anywhere between these? Does it stop anywhere between these? No. So continuous just means it doesn't stop between any 2 points. So that definition, even a graph like number 4, is continuous. Does it have an arrow? No, but it is continuous. A discrete graph is something that's countable. When you look at the last 2 graphs, you can count the points on there, right? How many points are on question number 8? 5. There's 5 points. You can count them. How many points are on question number 7? Infinite. Uncountable. Does that make sense? Okay, so what I want you to do is I want you to go to your vocabulary page that we put in your journal. And I want you to write a vocabulary word for discrete and a vocabulary word for continuous. So discrete and continuous. Bowden?
Discrete.
Okay, so discrete, continuous, here's how you fill it in. Your vocab page looks like this. You're going to put discrete on one of the flaps, continuous on another flap. When you open them, the definition should be on the paper. On the back of the flap, you're going to draw yourself an example. So I want you to come up with your own definition for discrete and continuous and draw an example on the back side of the flap. Word on the front, definition underneath, example on the back. Okay, I'm going to give you a couple minutes to do that. If you need help coming up with a definition, talk to your table. Yes?
So discrete is no continuation between one. No continuation between one.
Yes.
It's on this. So you have the word up here and this. That's no. It's here. This one and you write the example. The definition is also the definition is on the notebook behind the flap. No, you make up your own definition of it.
I don't know what it is.
I'll just have multiple color graph and we I'm gonna work with it.
After you think you have it, I want you to check, I want you to trade with somebody, make sure that their definition is also correct. It doesn't have to be the same as yours, but make sure it's mathematically right. Yeah. The definition on the paper underneath, and then on the back of the flap, draw an example.
There's no one. Yeah, but I expect you to be cool. Mine doesn't start. There's no one.
So there.
And then the street, I just said, okay.
Okay, the bell's gonna ring in just a couple of minutes. So that we are on track with the rest of my classes, I need you to copy this down. You have a chart here. You can put it on the back of your notes from yesterday, or you can put it on the front if you have room. But after you finish your definitions, go to that paper and write this. You have an open circle. With your open circle, you have inequalities that don't have a line. You have parentheses, infinity, and negative infinity. A closed circle is the inequalities with the equal bar and two brackets. Does that make sense? Then you also need to write this set of symbols, and this is what it means in words. And I'll make sure you understand it tomorrow. Today, take a picture or write it down. Okay? And after you've got that, then you can pack your things up. It's also on the video I'll post it for, but it's kind of blurry.